Good morning, class. I am your teacher, Mr. Otie Woflgang Smith, and today we're going to dive into logarithms. But before we begin, does anyone have any pre-assessing questions? Any questions that don't pertain to me being a dog? Nobody? All right, let's begin. To understand logarithms, let's first review exponents. An exponent tells us how many times a number called the base is multiplied by itself. For example, in the expression 2 to the third power, the base is 2, the exponent is 3, indicating 2 multiplied by itself 3 times. Now, let's introduce logarithms. A logarithm is the opposite operation of exponentiation. It tells us what exponent we need to raise a specific base in order to attain a given number. In other words, it helps us solve equations like 2 to the x equal to 8. Logarithms are denoted by the symbol log, followed by a subscript indicating the base. Let's look at some other examples. What would log base 3 of 9 be? 2. Let's look at something harder. Log base 4 of 1024. What do you guys think that'll be? The answer is going to be 5. Right before we move on, it's good to know that if a log doesn't have a base, then we automatically assume that the base is 10. And to add, if you see a natural log, ln, its base is e. Next, we have the product rule. This rule tells us that log base a of m times n is equal to log base a of m plus the log base a of n. It simplifies expressions involving the multiplication of terms inside the logarithm. This means that the logarithm of 12 is equal to the log of 3 times 4, which is the same as the log of 3 plus the log of 4. The product rule even works with variables. Log of 3x is the same as log of 3 plus the log of x. Moreover, we have the quotient rule, which states that the log base a of m divided by n is equal to the log base a of m minus the log base a of n. It simplifies expressions involving division of terms inside a logarithm. Here are some examples. Finally, we have to introduce the power rule, which is denoted like so. Log base a of w to the x, which can be written as x log base of a of w. The log of 4 is equal to the log of 2 to the second power, which is the same as 2 log of 2. Log of 7 to the 3x power is the same as 3x log of 7. In today's time, we can easily use calculators to decipher these computations like so. Oh wait, do we have a question?
How can this be used in the real world?
I'm glad you asked. Many scientists use logarithms to calculate compound interest, bacterial growth, decay, pH levels of any substance, and even earthquakes. We may not see logarithms, but they are used every single day. In summary, logarithms are a fundamental mathematical tool that enables us to solve exponential equations, simplify expressions, and analyze various phenomena. By understanding logarithms, we can unlock the power of exponents and tackle complex problems with confidence.